Welcome to this lecture on Arduino programming and hardware simulation platform. Let us see what are the basic steps of any project to execute it. Okay. The first thing, which is the most important, is the problem identification. And after identifying a particular problem, we have to formulate the problem so that we can solve it, because most of the cases the problems are very general and it is required to formulate it properly. After that, it is required to be analyzed, and after analysis we have to identify the list of components of the hardware, and accordingly you have to make a hardware connection, you have to write the corresponding program, and finally upload the program into the microcontroller if it is a control problem. Let us try to understand these steps once again through an example. So first, take the problem identification and formulation. Here for an example we have taken one problem. The problem is the real-time problem. Here it is actually formulated, not actually the exact problem. So in a chemical process plant, 3 different chemicals are to be mixed in a sequential order and in a periodic repetitive manner. Suppose we want to considering a plant of a mixing chamber, and where 3 different inputs are coming from 3 different pipes. Basically those are 3 different chemicals, and then according to their ratios they are mixed within the chamber, and after that they are discharged and goes to some other places. These 3 chemicals inlet valves are gradually opening in 5 seconds. Okay, suppose according to the requirement the valves are opening in 5 seconds. That means from fully closed to the fully open it requires 5 seconds. Chemical 1 valve will be kept full open for 25 seconds. Maybe chemical 2 valve will kept open for 15 seconds, and chemical 3 valve will kept open for 5 seconds. Okay, so let us try to understand. Say this is chemical 1 which is coming through this pipe and ultimately falling here, and this valve will keep open for 25 seconds at a full open condition, but this valve opening time may require 5 seconds. Okay, similarly chemical 2 and chemical 3 are also coming, and their valve timing and the time for that period it will keep kept open, that has been given, and these are definitely is a requirement so that a specific mixture is prepared within that chamber. Maybe if the chemical 1 coming for this much of second and this one is coming for this much of second, then a particular maybe pH will be produced in the chemical, or a particular pressure may be generated, or a particular temperature may be generated. There may be different kinds of process variables which are of main interest. To maintain those process variables, we actually have to control this valve. Suppose based on certain calculations it has been decided that this has to be done for 25 seconds, this has to be open for 15 seconds, okay, like that. But this way, if we do the problem, this is a kind of an open loop system, right? That means we are not actually taking any feedback that what is the final pressure, what is the final temperature, or what is the pH value, and accordingly the valve will be automatically controlled. It is a standard time that is given, say 15 seconds, 20 seconds, like that. So this is not a closed loop control system. Based on certain calculation, the valves are opening in this way. So I think you have understood this particular problem. Then again the process of opening from valve 1 will repeat in the same sequence. Maybe certain time is given that it will discharge out, and then again the chemicals will come, and suppose this process will continue in a process plant. And we have to make a hardware to execute this operation. So initially we are not taking the most general closed loop control problem that we have to take feedback of this temperature, maybe the pH or and all that, and accordingly valve will be changed. But let us consider we want to maintain this timing. Now let us see how can we control these valves according to this time. How can we do that? So this is what is the problem. So in this way, in a practical process plant, we can identify a problem and accordingly we can formulate. So here you can see what we mean by the problem identification and formulation. Most of the cases in your examination, maybe you have seen that some problem has been given, but when you go to the practical life, industry or somewhere else, you have to identify the problem, you have to formulate the problem, and then you have to solve. Okay, so this part of any project is the most important, rather more difficult and innovative challenges are there. So remember, at the end of this course, our ultimate object or the course outcome of this is that you will be able to control this valve according to this instruction by the electronic hardware that we are going to learn. Okay, but it is not that right now we will be able to do it. So for that, certain steps we have to follow, and we'll see that ultimately we'll reach maybe in the next week at this level, so that we can even closed loop control can be possible. Okay, for the time being, let us do a different thing. Suppose these actuators will be operated by some maybe motor or some kind of a servo motor, say. With the help of servo motors, this actuator will be open. Now, right now, let us not try to do it with the servo motor. At least what signal is coming, let us try to identify the signal that is coming here. That means you have to give certain signal to the servo motor so that the servo motor will keep open the valve for that particular time, and then again it will gradually close. So this signal has to be transferred to the servo motor, and accordingly servo motor will do the job. So this is what is the ultimate thing that we want to do. But right now, let us take a simple. Suppose there is an indicator. This indicator is an LED, and for each valve, let us consider one LED is connected, and the brightness of this LED will give an indication that what portion of the valve is closed. That means if the LED is off, that means the valve is off, and when the LED is at a full brightness or glow, that means the valve is completely open. In a partial situation, it is partially open. So if we can control the brightness of an LED by giving signals to this LED, the similar kind of signals we can give also to the DC motor, and accordingly DC motor will operate the valves. So that is possible. So the basic process will be exactly same. The main idea is how we can control of giving the voltage to this LED so that it will glow from off to gradually increase and ultimately full glow, or it will keep at that full glow for a certain period, or when it will close, so that means gradually its brightness will decrease and finally it will off. So this kind of a voltage control we have to give from the board or the Arduino board. So okay, so we'll see through this indicator that how can we vary this voltage according to our wish, according to the given problem. Okay, so this is the thing that we want to learn right now, and then when we learn what are servo motors and all that in the next week, we can also control the servo motors accordingly. After problem identification and formulation, the next part is analysis. By analyzing the problem, basically means select the appropriate mechanism of the valve control. That means to control the valve, different kinds of mechanisms possible, and those mechanisms can be of different kinds, so which one will be suitable for that valve. So that identification or design is one part. Definitely those who have already done the course of kinematics of machines, they knows that there are different kinds of mechanism by which we can generate different kind of motion, right? So selection of that particular mechanism is a challenge. Select appropriate driver, that whether you are using servo motor, then what is the size and specification of the servo motor. So these are again the design challenge in that area. Do all the required mechanical, electrical and electronics design calculations, and these are what we mean by the analyze the problem after identifying and formulating the problem. And finally we'll put certain program logic, and that is a part of analysis again. So basically by this analyzing part is a kind of a standardized. There are many softwares available in industry. So analysis is a very straightforward thing. Once the problem is identified, there are many expertise present, there are many softwares, so this can be done. Okay. And finally identifying the list of components which are required for that control, make a hardware connection, write the corresponding program and upload the program into the microcontroller. Basically these things we want to see right now in this lecture, how we do all these things. Okay, so how to do all these hardware connections, how to write program, that we are going to see. If you remember the first lecture of automation, so we are basically dealing with this part like sensors, control algorithm, maybe actuator. Okay, so this part is basically what is the control system, and we are basically dealing in this course on this particular part. So this is the interest part. Now let us take a very simple problem of how to control the blinking of an LED with Arduino. So let us see how we can on off an LED first, then we'll see how we can control the brightness of the LED, and gradually we'll learn step by step. The question is, then we need Arduino, we need LED, we need all these hardware things. So where we'll get this right now? Right now we do not have all this hardware. So what we do, we will take help of a simulation platform, and with that simulation platform we are going to do all this programming and the hardware part. Okay, so TINKERCAD is that particular online free simulation platform where we are going to do this thing. So let us go to this. TINKERCAD. What you have to do, you just follow these steps. First you have to go to the internet, and in the address bar you just write TINKERCAD, TINKERCAD, tinkercad.com. Then you will see this particular interface where it will ask you to sign in with the help of your Gmail. You can enter into this TINKERCAD platform. So you click on this sign in, and here it is giving either you sign up here or you can use the social networking site. Say we are signing in with Google. So here I am giving online course by electronics. This is one of my Gmail. I'm giving the password. Showing some problem. Let me check. Let me do it once again. Now it is signed in. Just try TINKERCAD. Just go to the login. Okay, this is the interface. So now here you can see, here it is written 3D design. So we will go to the circuits. So click on the circuit. So here you can create your new circuit. Okay, so here you can see create new circuit. So you have to click on create new circuit. So now you see this is the work area where you have to make the circuit. Here you can see the first thing that you have to do, arbitrarily one name of this file has been taken. So first thing is that you have to give a particular name to the file. So click on it and change the name. Suppose we are giving the name demo digital output. Demo digital output pin. So we have given the name of the file demo digital output pin. Then here you can see we have to select the components what you will require to make this one. So what we want to do, we want to create a hardware connection so that one LED can be, its blinking can be controlled like on off, but the timing will be according to our wish. So we'll take certain components. Definitely we'll take one Arduino board, Arduino Uno board. Here you can see the components. Here all components will come, here basic components will come. So here within the basic components we'll get our component. So simply drag it from the panel, you will get so one Arduino we got. Now here you can see you can move it by simply dragging the mouse. Now what extra thing we need? Definitely you want to control a LED, means we need an LED. So here we are taking one LED. Now LED can be of different colors, so you can choose the color. Let us take green colored LED. So you just select the color. Okay. So you have taken one LED, you have taken one Arduino board. And you know, if it is a 3-volt supply, then maybe no resistor is required. But if the voltage supply is more than that, here we are going to give a 5-volt supply, so we need a resistor. So we are taking one resistor. So definitely you have to give what is the value of the resistance that you are taking. We are giving a resistance of 330 ohm. Here it is the unit, you just choose ohm. So we have taken a 330 ohm resistor, because generally you just remember within the LED, if the current is within 20 milliampere, then it will not going to burn. But if it is more than 25 milliampere, there is a chance that it may burn, and that's why a suitable resistance is required to be taken. Now what extra thing you need? These are the things we require. Another very important thing, I think this is the right time to introduce with you this important electronic component that I missed out during the lecture of the components, that is the breadboard. Okay, so this one is the breadboard. So we have taken one small breadboard. Okay, by scrolling you can either zoom it or zoom out. So we have taken one breadboard. Now just you position it properly. So let me tell you one thing about the breadboard. What is the breadboard? In a breadboard you can see certain holes are there, right? So here you can see one line, and here you can see another line. Here you can see two rows. One is given, here you can see this one is given positive, this one is given negative. So you see, when you place your mouse here, it is showing that all these holes are connected. That means if you give power here, you can draw power from here. That means all these are connected by the conductor. Similarly, here also in this row also you can see all of these are connected. But if you come here, you see these holes are not connected along the horizontal direction, but they are connected in the vertical direction. So if you see, there are two rows like these first two, and here you can see the last two. They are connected horizontally. All of these are connected, and internal these holes and these holes, they are connected vertically. You see, these are connected vertically. You put it here, they are connected. They are connected. Okay, similarly here they are connected, and there is no connection between this and this. Okay, so this is what is the internal connection of the breadboard. So we can make use of the breadboard so that it will be many times easier. Less wires are required, robust connections are possible. Otherwise, practically doing all these connections with the wire, it will be very difficult. It's better that you just press it within the breadboard and make connection with the breadboard. Okay, so for the small projects, these are helpful. Now let us try to see what will be our hardware connection. First of all, here some power has to be connected. So when the power will be connected, then you know the power switch will be blinking, so you know that the power wave is connected. So here basically the power is connected, that is showing here, the power is there. So if power is there, then you can get 5 volt from here. Here you can see it is written 5 volt. So you can get 5 volt from here. So what we do, we just simply take 5 volt from here. Take 5 volt, press your mouse and simply drag it. And in this way, you just take this power tool and click at this position. And now if you click on this particular wire, you can change its color. Let's make it red. So in this way, what we have done, basically from the Arduino we have taken a 5 volt and we have given supply that 5 volt to this particular row. Clear? Now what we are doing, we are giving supply to the negative with the ground. So here you can see the ground. So what we are doing is, we are giving supply ground, so in this way we can given supply to the ground. So all of these holes are now at ground. Okay, now we have to connect the LED. So to connect the LED, we take the LED here, and here you can see one leg of the LED is bigger than the other one. If you take a close look, here you see this leg is larger, and this is basically the anode, and the smaller one is the cathode. Okay, because from the same position these two legs are coming, and at the same position the two legs ended, that means same horizontal position, but this is at an angle, that means definitely this one is a larger. And here this one is anode, this one is cathode. If you put your mouse, then you can easily understand. And we also know that the shorter one is the cathode and the larger length was anode. So what we do, the anode is to be connected with the positive or the 5 volt supply. So if you connect the LED here in this way, then what we do, that we will connect it with the 5 volt. So 5 volt is already there anywhere in this layer, 5 volt is there. So what we do, we simply connect 5 volt from here. Sorry, we will connect it to the to a pin. So what we have done, we have connected this one with the pin 13, where we are going to get the output. And what we are doing, so output is basically 5 volt, but the 13 pin will get accordingly what we will program. 13 pin will get accordingly the output. We'll see that how we'll send the output at the 13 pin. You know, if we connect it with the 5 volt supply, then always this LED will glow, right? Because it will, the circuit will be completed. So the 13 pin, we have connected it with the 13 pin, so that in a 13 pin we will program in such a way that this 5 volt will go supply 5 volt in the 13 pin when it is required, and it will not supply anything in the 13 pin when we want it to be off. Okay, so our program will be such that the 13 pin will be controlled, and accordingly this LED will get the voltage. So if we directly connect it with the 5 volt, then what will happen? All the time LED will glow. And now we'll connect the other end with the ground, but we have to connect the resistance with the series. So that's why we'll take the resistance from here take the resistance from here and connect it. So here you see the connection. Here you see these all holes are connected. That is why only this much is sufficient. Here similarly all these are connected. So from here it goes to here. That means at the ground, because all these are connected and this one is connected to the ground. That means this is basically this end through this resistor is connected to the ground. And resistor should be in the series circuit anywhere, either in this end or in this end, no problem. So our circuit is completed. Okay, so this 5 volt that we have connected in this way is redundant. Basically you can remove it also. I have just shown you that if we connect directly this with the 5 volt point, then what will happen? It will always get 5 volt, but this is not our intention. Our intention is to control its blink. When we want it will glow, when we do not want it will off. Okay, so now how we can do it? The circuit is now clear. Okay, so now we'll go to the coding section. Okay, we'll go to the coding section. So here you can see code. So click on it. Here you can see the coding can be done in the form of blocks also. This is called the block coding, where you need not to remember the syntaxes for the C programming, but I will always prefer you do it in a proper programming mode where it is written in the form of C. It is similar to the C language. You just delete whatever is there. Okay, so here you can see there are two very important functions are the whole thing in the microcontroller programming. One is the void setup and another one is the void loop. This void indicates this particular function is not return anything. That is what is the meaning of void. Setup means this particular function, within that we basically define the different pin, whether they are input pin or they are output pin. These things actually described within this function. These are called setup. And in the loop, this is basically an infinite loop. Whatever you will write within that particular thing infinitely will be in a loop. Unless otherwise you stop it, then it will continue, or you remove the power, it will continue forever. So one infinite loop which is called the void loop function, and another one is a setup function. So here what we want to do. So first of all, in a C, those who have already done C programming or some idea about the programming, you know that it is always better you write the comment. Comments are certain lines, those are not executed when the program is running, right? So but those helps us to understand that what the different lines are, right? So initially we are writing something that this particular program is about this particular thing is about control of LED blinking. Okay, so let's also further define the problem that we want that this LED will be on for say 5 seconds and then off for 5 seconds, and this process will repeat. Okay, so this is what we want. Okay, so this is what we want. Now we want to make this as comment so that these are actually not part of our program. So for that we have started with the slash star and end with the star slash. Then you can see the color has been changed. So here in this way we can make the whole paragraph into a comment. But this will help you. What is the problem that we are going to do? This is very important step. Now in the setup I have already told you we have to define the pins. Here in which pin, with which pin the LED is connected. LED is connected, you can see, with the pin number 13. Okay, so we'll write that pin number 13 is the output of this LED, right? So what we write? So there is a command called pin mode. This is the way you have to remember. This is a particular function by which the pin specification is done. So pin mode 13, this 13 pin is what? This is the input pin or output pin. Output pin. This is the output pin, the voltage output pin. So output, remember it is in capital. So 13 comma output and then colon. So this is what is the output pin that we have defined. This is what is the only thing required, that is setup function. Remember, setup function is not going to loop. The loop function will infinitely loop. Now in the loop function we have to send information so that this 13 pin will get voltage such that this particular thing will be executed. That means for 5 seconds it will be on and for 5 seconds it will be off. Okay, so for that what we do, we'll write one function which is called digital write. Okay, digital write. One important thing you have to remember, that pin and then capital N. So first word, if that particular name is of 2 words, then the first word as if the small letters and the second word starting letter is capital. In this way most of the cases the functions are defined. So digital write. Okay, so digital write will define that the 13 pin, digital write means something is given to the pin. What is given to the pin? 13 pin is given high voltage. High voltage means 5 volt supply. So HIGH, this is high. High means it is getting 5 volt supply. But for how long it will get 5 volt supply? According to our problem, it will get 5 volt supply for 5 seconds. So we have to give a delay. Delay is another function. All these are library functions that we are using. Okay, digital write, delay, pin mode, that you have to remember. So delay for 5000 millisecond. Okay, so here the unit of this time is in millisecond. So 5 seconds means 5000 millisecond. Okay, so this is, that means that this will get for the 5 seconds at a high condition. So the 5 volt supply for 5 seconds. Then what we want? Then we want to off this thing. So again we will just copy this portion and Control V. So what we can do in between, we can write, or here we can give comment line so that you can remember. 5 second delay at on position. Okay, by this slash actually this will be this is not going to be a part of the program, but that will help you to refer after that. Similarly, 5 second delay at off position. In this way, basically, in the pin number 13, we have given 5 volt high, and for the second part, we have to give it low. Low means it is getting 0 volt. That means LED will not glow at that time. And then it is under infinite loop. So the same thing again and again will happen. So our program is over. Okay, and you can make this program more in a better way. You can write this program where you can see that this, instead of this 13 pin, if we just connect it to some other pin, say we connect it to say pin number 12, then what we have to do, tell me, in the program? Instead of 13 we have to write 12, right? But we have to write 12 in how many times? Here, here, here. So to avoid it, we can define a global variable. Say we are defining a global variable which is say green LED. Green LED. We have defined a global variable. This is our choice. You can consider X, Y, Z, whatever. I have taken the name of the variable green LED. Okay. So this green LED is what? This green LED is 13. But remember, this particular variable is an integer variable. So that is why you have to specify its type. So int space that variable. That means that variable is an integer variable. And green LED is what? Basically it is nothing but the number 13. So instead of writing 13 many times, what we do, we just write this green LED here. So in this way, this program is now looking better. So if you change it to 12, what we do, you simply change here, it is 12, then automatically you need not to do any other further changes. Clear? Now let's run it and see whether according to our wish the LED is really glowing or not for 5 seconds or not. Let's see. So here you can see start simulation. So you click on it. Now see, for the 5 seconds it is glowing and then it is off for again 5 seconds. So here you will find the timer. So you can check whether it is matching with that time also or not. So I hope you can see. Clear? So in this way, basically we can do it. Now what we'll do, after writing it here, if you really want to implement in the actual hardware, you have to make this Arduino connection. Then you know how to connect Arduino with the computer with that USB cable, right? And then what you have to do, you just copy this portion. That means the whole program you just copy and for actual implementation, and go to your actual Arduino software. And simply delete it and paste it, and then you have to verify it. Just click on the verify. You see it is asking for save. Okay, let us save it within Arduino. Now it is compiling and it is checking whether there is any error or not. So here you can see there is as such no message, and that is not going to make a problem here. This is just an information. So otherwise you will find a error message, and accordingly you have to change it. Okay, so everything is done. After connecting with your Arduino board, you have to simply upload by clicking this one. That's all. Then you will automatically see that within your Arduino board, where the LED is connected, it is glowing whatever you have seen in the Arduino simulation platform. Okay, but this stage you need not to do, because right now you may not have that hardware things, practical hardware things, so you just do it in the simulation environment. Clear? So we have seen basically how can we control the digital output pins, because the pin number 13 or 12, whatever that may be, that was the digital output pins. So that we have seen by controlling the blinking of an LED. The next class or the next lecture we'll see how to use PWM pin and how to display in serial monitor. Thank you.